I'm Mark, I'm here with Nick, and we'd like to welcome you to this presentation on delivering secure apps. As we navigate digital transformation, there is probably no topic more important than defending yourself against attack. First, I'd like to say it's great to see everybody here today and to know we're back doing in-person events. Thank you for choosing to spend your time with us. And also a call out to those joining online. Thank you for joining. So this is the agenda. We're going to split it into two parts. Nick's going to be covering GitHub Advanced Security, and it will be mostly demo. So I know that will be welcomed by most people. And then I'm the warm-up act. I'm going to be covering security fundamentals. Now, security is complex because it contains many facets, and therefore you need a variety of skills. I want to frame a conversation how we must eliminate silos across teams and then embed a security-first culture into our tooling and processes. So security is all about protecting the business. A subset of security is information security, and that's all about protecting data and associated applications. Again, is critical for the success and survival of an organization. Now, there are three core objectives of InfoSec. Confidentiality, ensuring our data is protected against unauthorized access. Integrity, ensuring our data is accurate, consistent, and protected from unauthorized modification. And then availability, ensuring our data is available as and when it is needed. Now, most of the conversation around InfoSec is about defending against malicious attack, but there are some other events you need to take that can cause risk to your data. So an example is acts of God. If there's a lightning strike and it takes out your power supply, is your applications and data protected? InfoSec is also about making sure everybody does the right things and does those things right. So, for example, there's no point having a backup policy if no one actually adheres and does the backup. So cybercrime is a huge industry. There's many, many bad actors out there attacking organizations of all size, whatever their purpose is. The problem is swelled by the fact that bad actors don't have to be super intelligent. There is exploits freely traded on the dark web at low cost, enabling such people to participate in such things. Now, it's often the case that you just have to exploit one vulnerability, and then that becomes a stepping stone into your other systems. People, once they compromise that, they can then laterally move through your applications and your networks until they find a place where they can launch a more hostile attack. Now, bad actors do bad things. In many cases, it will cause severe financial impact. So it could be things like loss of customer trust, loss of intellectual property rights, could be corrupted data, could be compliancy fines. In worst case, it could cause business ruin. And in the most catastrophic case, a malicious cyber attack could cause loss of life. And as we can see from the slide, all the advantages are with the attacker, or I should say, the large number of attackers. Now, a key part of InfoSec is managing your risk. This is about keeping a register of all the things that are risks, and for each identifying what is the likelihood that it would be exercised and what is the impact that it would cause. And you end up with, one extreme is unlikely to happen, but if it does, it doesn't matter. Other extreme is complete disaster and highly likely to happen. But in most cases, it's going to be somewhere on that spectrum. And then it's a business decision to decide how you're going to handle that risk. So you could avoid it. You could do something different just to eliminate that risk. You could accept the risk as just the cost of doing business. You might transfer it, and an obvious example is to take out insurance. Then the last one is mitigate. That is all about doing things to lower the likelihood and to lower the impact. And to reduce risk breaks down into 4 categories: secure by design, secure the code, secure the environment, and secure the operations. So the design, we do the design obviously before we cut any code, and it's all about mapping user requirements onto architecture and identifying things such as the platform, the components, the software we're going to build, any personas, and all the interactions between them. Then what we do is we pass that through threat modeling, and that uses people with a different skill set who think like an attacker, not like a defender. And they can use their threat modeling techniques to tease out flaws in that design that then get put back and fixed in the actual design before it's signed off. Zero trust is the way that we now think about networking. In the past, we'd have the internal network, the external network, stick a firewall between the two and keep the bad guys out. That no longer works. Today, you've got your trusted employees working on untrusted networks, and we have to assume breach. Highly likely there's going to be untrusted people on your trusted networks. What we have to do is move away from protecting the network segment to protecting the resources. So what we mean is we trust nothing. Everything has to be explicitly verified to ensure we've got a high level of assurance it is what it claims to be. And we want to reduce the blast radius. We do that by making sure everything runs under the least security context that it needs. So if that got compromised, it makes it harder for people to move through your networks. So identity here is obviously really key. Do not reinvent identity. Use, because it's a big popular attack vector, use the industry standards that exist around identity and use solutions, product libraries from vendors that have invested really heavily from an R&D point of view, and their products are kind of battle proven. Data classification, that's kind of understanding your data and treating it appropriately. So if you've got personally identifiable information, if there's a leak of that, huge compliancy fines. And then transport and storage, just make sure everything is encrypted when it's at rest and in transit. Secure the code. So this is back both your code and external code, so if you're pulling in open source. So the first thing is to use code scanning tooling. So what that can do is check its quality, it's reliable, it's written to standards. So in essence, what we're doing is we're automating the code review that traditionally we would have had peers doing. Static analysis, again, it's tooling. What it's going to do is look for suspect code. Secret management. Do not store secrets, security tokens, passwords in your source code. If you store it in Git, it's going to be there forever. Even if you remove it, it's in the history. So if we've got credential scanning, it can identify if anybody's done that. Dependency management and supply chains. That's a big topic. I've got another slide on that later shortly. Secure the environment. So when you use a cloud service, there is shared responsibility. The cloud vendor will put physical security, but you've got to lock down your resources and your environments. And the analogy here is, if you've got a castle, it doesn't matter how high the walls are, doesn't matter how many crocodiles you put in the moat around the castle, if you leave the drawbridge open, an intruder will just walk in and party in your castle. So it's your responsibility to provide access controls to define who can actually come into your environments. We use policies. Policies are centrally configured. They're guardrails that conform and ensure governance and make sure there's no misconfiguration. Use infrastructure as code, so any of your resources, use scripts and templates to define those resources and then use that for provisioning. That kind of then we store it in version control, which then provides that kind of quality, consistency, accountability, repeatability. Networking have network devices that can filter out network attacks. They can defend some of the OWASP Foundation, those threats defined by them. Last one, OS patching. Make sure all your VMs are patched to remove any vulnerabilities. Now, in today's world, we'd be encouraging people to use platform as a service, but if you're using cloud-native Kubernetes, there's still VMs under the covers. Secure the operations. So these people are responsible for protect, detect, and respond. And when it comes to respond, make sure everything is scripted. When you're under pressure, things are going wrong, you don't want to be thinking on the fly. You just want scripts that can run. You need to do threat intelligence, understand the landscape, so you know what threats are likely, and then you can plan accordingly. You don't want to have any surprises. Forensics and root cause analysis, that's for the operations to, if there's a post-incident, then you need to kind of look in and see if there's any compromise to your confidentiality, your integrity, and your availability. Last one, disaster recovery. So you need to be, based on what the organization, the business requires, you need to be able to cover from any kind of disruption and disaster. So there's a lot there. And the key takeaway was there's a lot of skills that's needed. Also, to be successful and effective, automate as much as possible. So open source is very popular today to speed up development. Why reinvent something if somebody's already solved that problem? So open source is good, but it comes with risk. When you pull in a library, it pulls in multiple other libraries, and each one of those could pull in multiple other libraries. And in the end, you can be bringing in a lot of software that you don't actually know what the source is, what the root is, who wrote it. It's not unusual to pull in one library and you actually pull in 4,000 libraries. What you need is software tooling that will explain your software bill of materials and then can identify if you're pulling in any software that's got vulnerabilities and if it's pulling in any software that's got licensing that mandates how a commercial organization could use it, and it might not be in line with what your legal people are happy with. So DevOps. DevOps is the engine that drives innovation, and you can develop at a much faster pace than you can with traditional software development approaches. We talk about the inner and outer loop. So the inner loop is where your developers are doing their coding and debugging, and then they will submit it into the central repos. And then we've got the outer loop that is doing your build of your software, your deployment to the different environments. Then you've got the ongoing monitoring of your applications, and then that's kind of driving the next iteration. The evolution of DevOps is DevSecOps. And the idea of this is to embed all those security practices into the inner and outer loop and create that security-first culture. So what it means is your software developers, as well as building high-quality code, they're doing security as they go. Security shift left is doing as much as possible earlier in the software lifecycle. If we shift left, we build more robust code, we save costs, and we accelerate delivery. With that, I'm now going to pass on to Nick, who's going to talk about GitHub Advanced Security.
Perfect. Thank you ever so much. I think we can all agree that was no warm-up act. So firstly, fantastic job. Okay, so it's now time to talk a little bit around GitHub Advanced Security. So some of you may have heard of this, some of you may not have heard of this. Advanced Security is really a tool that, again, tries to shift security left, but it doesn't just do it in that shift left way. I think like everyone in this room and everyone watching online is probably used to this terminology, shifting left. It means trying to find bugs, trying to find problems earlier in the developer lifecycle. But one of the key things about that, right, is you're actually shifting a lot of responsibility onto the developer. When you didn't shift left, right, you had security people that were dedicated to security. So these security tools that were currently out there today, they were really aimed and really focused on the security person. Now, what happened is we shifted that left. So what we've done is we've taken the current tools that were out there and we've shifted them left and said, hey, developers, have fun using these tools. And we've seen this real big problem in the security market, especially for the developers in the room, where like security is this second-class citizen to the software development model. Like if you ask a developer, like, what do you enjoy about your day job? Not many of them are going to say security. And the reason being, a lot of these security tools are meant for security people. And all we've done is we've shifted them left and said, we've automated everything. Life is great. But the problem is, developers aren't really enjoying these tools. And an analogy that I like to use is if you went for surgery tomorrow, you would want your surgeon to use tools and apparatus that were meant for that surgeon, because you get the best success rate, it would be done in the best time. If that surgeon was using tools that wasn't meant for that surgeon, it would go slow and not very well. So let's put that in the hands of developers. Why are we okay with giving tools to developers that weren't meant for developers? And that's the real big problem we see today in this whole security market. Now, that is where developer first comes in, and versus shifting left. In the industry now, you're hearing a lot of phrases like developer experience and developer first, and that is exactly what GitHub Advanced Security is. It's a developer first security tool. So going through all of these in a bit more detail, code scanning, think of code scanning as the experience around fixing vulnerabilities. In that very brief 20-second demo that you all saw, you likely saw the status checks at the bottom. So code scanning is inbuilt status checks. It's also inline annotations in pull requests, so developers don't need to go ahead and find vulnerabilities. It's that audit history. Everything a developer needs to find and fix a vulnerability, that is what we call code scanning. Now, for the devs in the room, one of the real nice, exciting features here is you probably diversify your tool set, right? So you may be, if you're building a JavaScript app, you may be using ESLint for quality. You may be deploying a container app, so you may have some container scanning, some infrastructure as code scanning, like TFSec if you're doing Terraform. Now, these are like 5 or 6 different tools for you to go to, right? The nice thing about code scanning, it's tool agnostic. You can per se run all of these tools in your CI, GitHub Actions and Azure Pipelines, let's say, and upload the results into code scanning. So that means developers no longer need to leave GitHub to find the results. And going back to what I mentioned earlier, you're then creating this developer-first experience, and you're making security a first-class citizen of that software development model. So think of code scanning as the experience. Now, you do get an engine behind that, and our engine is called CodeQL. Now, I won't get too technical here because it can get quite into the weeds, but think of CodeQL as a static analysis engine. But it does static analysis in a very different way. We try and per se rule out the false positives, and we really try and give developers as many true positives as possible. Again, the worst thing for a developer is when they get this PDF of like 600 results and they're like, oh my goodness me, no way. And I've been there, I'm sure a few people in the audience have got that report of hundreds of alerts and gone, oh, that's the next 2 hours done. So again, what CodeQL tries to do is let's not give false positives to the developer. The way that we do that, for the people in the room, I am around after, I'm more than happy to per se dive into that. Now, a big part of the thing is also secret scanning, and this is probably one of our flagship features, I personally believe. Every developer has accidentally pushed a .env, they've maybe forgot to add it to their .gitignore file, and they're sitting there like, oh, I just pushed up all these secrets, and they're either going to do one or two things. They're going to do what a bad developer does, and they're going to be like, no one's going to see that. I'll leave that right there. Or they're going to go, all right, I need to remediate and revoke these tokens. And for the next 2 hours, they go through the ENV. If they're using some AWS credentials, they'll go ahead and rotate there, maybe some Azure RDS credentials too. And again, they'll waste the next 2 hours. The nice thing about secret scanning is, let's say that we have some devs in the room and they push a .env by accident. Secret scanning will detect in that commit shard any secrets, and it will reject the commit, push it back down to the developer and say, hey, we've detected some secrets here. We recommend that you go ahead and remove them before we push it up to GitHub. So imagine that as an organization and as an enterprise, you have assurance that, hey, no more secrets are going to be leaked. And in the latest Verizon data breach report, credentials are now one of the most exploitable ways for enterprises to get exploited. Credentials are becoming so important. The other part about secret scanning, you click one button, we'll also find all of your secrets in your code base that matches patterns that we have, and obviously we have many Azure patterns in that. You can also define your own patterns for secret scanning. So this is a really nice and simple solution for companies to use to really focus on finding your secrets. Now, fourthly, security overview. This is more for the security people in the room or online watching, and they're like, I don't want to go to every repo to see all of my secrets. Like, show me that macro level view. And that is exactly what security overview is. It cascades all your data up from every repo and shows you it on the organization and the enterprise lens. So you as a security manager, you can see, show me all my high-risk repos that leak the most secrets, so I can go ahead and do an educational campaign. And think how powerful that is, right? A lot of these companies out there today don't know what they don't know. And like when we go to them and start talking about security, you hear them be like, yeah, well, like, we know we have some problems, but it's not that bad. They then enable secret scanning and go, oh my goodness me, like, look at all these secrets. So you're changing that story, right? You're now empowering organizations to go from, I don't know what I don't know, to I now know what I know. So again, it's that very powerful story around changing data, and security overview is exactly that. Now, finally, for people that use GitHub today in the room and online, you're probably used to Dependabot. It will help, per se, find any vulnerabilities in your default branch. Now, a few of you are also now probably thinking, it annoys me that it's not in the pull request. Like, why isn't it in the pull request? Dependency review is exactly that. If we want to go ahead and find all your vulnerabilities in a PR, let's say that we have a pom.xml for a Java app or a package.json for a JavaScript app. And again, like me as an open source maintainer, when someone brings in a new package, I have to go to npm, check its license. I then have to go and validate and make sure that it hasn't got any vulnerabilities. With dependency review, you click one button, we will show you if you have any vulnerabilities, but we will also show you the license. We'll show you the number of downloads. We'll also show you when it was released. I had a great example the other day. A developer introduced ESLint, which is a code quality package, from 8 years ago. Like, why would you do that? And that's where dependency review, it gives you more than just the per se, the vulnerabilities. And again, you're empowering developers to make more data-driven conversations. Now, there is actually so much more to advanced security, but I think just to summarize here, we really want to try and focus on being developer first. That is a core mission statement to us. We disagree with this industry standard around more alerts equals success and like volume equals good. Let's focus on what really matters, and let's make it a first-class citizen of that software development lifecycle. And that is really what advanced security is. And that's what I wanted to show you in the demo. But hopefully that overview really at least gave you a little bit of a summary. Now, I only have a few seconds left, so I just wanted to share some resources. On the left-hand side of your screen, I think, you can see the Azure specifics that was covered earlier. And again, you can also see some of the general stuff, like there's some GitHub things in there as well. So I really recommend checking out them links. I am around if you have any questions. Thank you, Kate. I will pass back to you.